Hi everyone, myself Satya, Department of Mathematics, SNS College of Technology, Coimbatore. In today's class, we are going to have the topic Eigenvalues and Eigenvectors. So through design thinking concept, we are going to elaborate the concept Eigenvalues and Eigenvectors. So Eigen-Insights, so which is going to unlock the data using design thinking concept. So here we are going to transform the complex data challenges into inducive, actionable solutions. Okay. And first thing we are going to see what is meant by a design thinking. So which is leads to the innovation. Okay. So design thinking is a human centered approach. So here we are going to have the innovation that integrates the needs of people, the possibilities of technology and the requirements for business success. And there are 5 stages. Stage 1 is empathize. So here we are going to have users needs and the challenges, and in defined case we are going to articulate the R, we are going to narrow down the problem statement, and in third step we are going to have the ideate part. So here we are going to have the solutions. So we'll have diversity solutions, right? And in fourth stage we are going to have the prototype. So in this case we are going to build the tangible representation of solutions, and we are going to test it in the last stage. So test with the users. If it is okay, we are going to proceed with that idea. If it is not okay, we are going to redefine the problem statement. Okay. And the next thing is eigenvalues and eigenvectors. So here first thing is eigenvalue. So this is nothing but we are going to represent the strength or magnitude along a specific direction. Okay, they tell us how much the scaling or stretching occurs, which will be shown in the first figure. And we will have the equation AV equal to lambda V. That lambda is called the eigenvalue. Okay, and the eigenvector is V. Okay, so these are special vectors. Which one? That is the eigenvector. Okay, and when a linear transformation which is applied to them, only the scale, which means the stretch or shrink, but don't change the direction. Okay, they reveal the principal directions of variance or influence within the data. Okay. The next thing is we are going to empathize. Okay, in this case we are going to have the user's needs and the challenges what they are facing. Okay, so we are going to understand their data. Okay, that is the personality. Okay, just as design thinking which begins with understanding the users, and applied linear algebra which starts with understanding the data. Okay, so in data exploration we are going to concentrate 3 cases. First one, we are going to identify the outliers and missing values. Second thing is understand the data types and the scales. Third thing, visualize the distributions and the correlations. So this phase which is going to gain the intuition which much like understanding a user's emotional landscape before defining a problem. Okay. The next thing is we are going to have a defined part. So we need to pinpoint the system's essential directions. Uh, essential directions. Once if we empathize with the data, we can define the core problem or insight we seek to extract the eigenvalues and eigenvectors. So 3 things are to understand. The first thing is we need to identify the key variables. So which features are most impactful, that is the thing we have to identify. Okay, and the second thing is we need to formulate the hypothesis. So hypothesis, it may be true or false, but we need to formulate the hypothesis. Okay, so in this case what are the underlying structures which might exist, that is the thing we have to see in the second stage. And in the third stage we need to define the problem clearly. Okay, clearly the state what the eigen analysis will solve. Example, dimensionality reduction, feature extraction. Okay, so this stage is crucial for framing the mathematical problem in a way that yields the meaningful and interpretable results. Okay, that way I have to redefine the problem statement. Okay. The next thing is we need to ideate That means we'll have lot of ideas, so we have to accumulate all the solutions, okay, and among that solution any one solution which is comfortable and which is suitable, okay, optimizable, in all case I have to check, okay. So that is how to select from this stage, okay. So brainstorming the solutions for data transformation, okay. So ideation in the context of the eigenvalues, which going to involve the exploring various approaches to linear transformations and their applications, okay. And in this case we need to check the principle, so we will have lot of cases, right? So we'll see one by one. So the first one is principal component analysis, that is PCA, okay. How can we reduce the data dimensions while retaining the maximum variance, that is in the first. Okay, and the second thing is spectral clustering. That means can eigenvalues and reveal the hidden clusters in complex networks. Okay, that is the thing from check it from the second one. And the third one is image compression. So how can we use eigenphases or singular value decomposition for efficient image representation. Okay, and the third thing is page rank algorithm. So understanding web page importance through the eigenvector centrality. Okay, these are the points. Okay, from ideate part we are getting. Okay, we will move on to the next stage, which is prototype. So here we are going to visualize the eigen solutions. Okay, that is shown in this figure. Okay, visualizing and computing the eigen solutions. So here in this case, prototyping involves tangible representation. Here it is about computing and visualizing the eigenvalues and eigenvectors. So computational tools are Python with NumPy, SciPy, R with eigenfunction, MATLAB for numerical linear algebra. These are the computational tools. Okay, visualizing results are scatter plots of transformed data, vector plots showing the directions, heat maps for covariance matrices. Okay, these are the results I have to remember. Okay, and the next thing is testing. So here we need to validate the solution, right? So which is in the real world application and that how it is interpreted, that is very important. So testing is about evaluating if the derived eigenvalue solutions actually solve the problem or provide the desired insights. That is the thing I have to check. So three cases I have to remember in your mind. The first thing is interpretability check, and the second one is performance matrices, and the third thing is user feedback. So this stage, which ensures the mathematical model is both robust and relevant. It should be both, right? Yes. So the next thing is we need to iterate, that is redefining the model or deepening the understanding. So design thinking, which is the iterative method, and so which is working with eigenvalues, which is insights gained from the testing, which is lead to the refinement. So okay, we can redefine the problem statement if it is not okay. Okay, so we will have evaluate the parameters and explore the new data features and continuous improvement and deepen interpretations. Those things are to remember. So from this, so the synergy, that is the conclusion is, so design thinking for advanced analytics. So by integrating design thinking, we move beyond just computation to create the meaningful and impactful data solutions. So it should be human-centered and actionable outcomes. Unlocking the full potential of your data, one thoughtful eigen insight at a time. Okay.